Alright, we have a circle C is drawn on the coordinate grid with center at -3, -4, and a radius of 8 centimeters. So let's go ahead and plot that. 1, 2, 3. 1, 2, 3, 4. Has a diameter, a radius of 8 centimeters. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. So somewhere out here in space. 1, 2, 3, 4, 5, 6, 7, 8. Again, somewhere out here in space. So we get an idea what our circle kind of looks like. I know it's kind of ugly, but it'll work. Alright, so let's translate 5 units down and 3 units right to produce circle C. So down 5 units down, 1, 2, 3, 4, 3 units right. 1, 2, 3. So here is C prime. Again, don't forget we also still have the 8 diameter going all the way around. Then C is dilated. C is dilated by a factor of 3/4, using the center of C as a center of dilation. So what we need now is the coordinate. So that's going to be at 4, 5, 6, 6. So C prime is at 6. It's going to be -6. And it's down 2, 3, 4, 5, 6, 7, 8. Alright, so we're going to apply a scale factor at 3/4. So we just take each number, we're going to multiply that by 3/4 to find our new coordinate at C double prime. So -6 times 3/4, that would be 6 times 3, which is 18/4, which reduces down to 9/2. And 8 times 3/4, that's going to be 8 times 3, 24 divided by 4, which is 6. So -6. That is my answer for that. And if it had a radius of 8, so we're going to multiply that by 3/4 as well. So again, that's going to give me a radius of 6. So my radius is 6. My coordinate is at -9/2, -6. Question 7. We have a triangle shown on the coordinate grid. If the triangle is rotated 90 degrees clockwise, so it's going to go this direction. It's going to go this direction. About the point -1, 1. So point -1, 1. And then reflected through y equals x to produce an image t. What is the vertices of t? Alright, so let's first apply our first rotation. Alright, so from this point, it's going to be 1, 2, 3, 4, 5. So it's 5 that way, so we need to go up 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here's our first location. And then it's reflected through y equals x. So y equals x, remember, is this imaginary line goes through our graph, kind of like this. Alright, so if it's reflected over this line, one more count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my t is going to be at that location. So the coordinate for that point is going to be 1, 2, 3, 4, 4. -4. And then counting down, 1, 2, +4, I apologize. And counting down, 1, 2, 3, 4, 5, 6. That's going to be a -6. So 4, -6 will be my final answer for that. Okay, question number 8. In this diagram, we have a triangle and another triangle, and they are congruent by this statement. And it says that A is congruent to OD. So to prove that AGE OLD are congruent by SAS, a side angle side. What other information is needed? Well, if it's side angle side, we need to show that this side is congruent with this side. So I need to show that AG is congruent to side OL. So that would be the correct way of writing that. Okay, question number 9 on the coordinate grid. Unit squares A, B, C, D, E, F, G, and H together form the figure shaped like the letter I. So here's the figure. The following transformations are applied. Square A is translated 4 units down and 2 units left. So the point up here, 4 units down. 1, 2, 3, 4. 1, 2, 3, 4. And then 2 units left. 1, 2. So it would wind up right here. And at this point, it's doing the rest will go. So basically overlapping A. So right here, A overlaps E. Okay, next it says square C is rotated 90 degrees counterclockwise about the origin. So counterclockwise goes this direction about the origin. So 2, 2, so essentially it would wind up right here. So this will be my new C. Square H is reflected across y equals x. So if it's right here, that means that if it's reflected, wind up like this. This point right here would be right here, so this would be my new H. Okay, a figure in the shape of what letter is formed by the squares of after the transformations are applied? Well, looks like I really don't have a letter. If you guys can figure that out, let me know, and I'll take it. But that's what the transformations is, the correct transformations applied. So let's go ahead and move on. Question number 10. Triangle PQR is congruent to triangle STU. Complete each part. Alright, so ST matches with PQ, and PQ is 8, so that means ST is also 8. PR matches up with SU. SU is 12, that means PR is also 12. Angle Q matches up with T, so T is not marked, so we don't know how big. Oh. Yeah, so we're not really sure. Q and T, not marked, so I'm not sure how big that angle is. Alright, moving on. Angle S. Angle S matches up with angle P, that's 53 degrees, so S is 53 degrees. Well, I guess we can figure this out for Q. All 3 angles inside of my triangle should equal to 180. If we know what 2 of them are, we can figure out the third one. So 180 minus 32 plus 53. So this will equal 95 degrees. Alright, so angle Q is 95 degrees. Okay, question 11. State whether the triangles could be proven congruent, if possible, by side, or side angle side. Then write the congruency statement. Alright, so in the accompanying diagram, it says that ZY is parallel to VY. Okay, so these are parallel. Let me draw some triangles there. Alright, and then it says that WZ is congruent to VY, and they share this side. Alright, so let's see if this is good enough. Alright, so according to our rule, we know that when we have 2 parallel lines, we have a transversal line, we know that alternate interior angles are congruent. So it looks like my 2 triangles are congruent by side angle side. Alright, so let's match up my triangles. So we can say that triangle LWV is congruent to, for instance, triangle V, Y, z. And those should all match up. Okay, question number 12. What method could be used to prove the triangles below are congruent? Alright, so we have a side, we have an angle, side, and both triangles are sharing this side right here. So that would be side, angle, side.